China's Mach 4, supersonic aircraft. The future of high-speed flight, ladies and gentlemen, distinguished viewers and aviation enthusiasts. Today, we are standing at the edge of a remarkable breakthrough, one that could reshape air travel, collapse distances across continents, and redefine what we consider fast. While the aerospace world has been buzzing with military hypersonic tests and advanced fighter jet programs, this time the spotlight is on something different. A commercial supersonic aircraft capable of reaching Mach 4, 4 times the speed of sound. A Chinese aviation company, Sichuan Lingkong Tianxing Technology Co., recently unveiled a prototype from its next-generation supersonic Yangxing series. The aircraft, named Quantianhou, also known as Soaring Monkey, is part of China's ambitious effort to bring supersonic commercial travel back to life and push it far beyond anything the Concorde ever achieved. Introduction: a new vision in air travel. The unveiling took place in Chengdu, the capital city of China's Sichuan province. In a statement shared with Global Times, the company emphasized that this prototype is not just a technological showpiece. It represents a bold step toward making ultra-fast, long-distance commercial flights a reality. Chief Engineer Deng Fan summarized the project with an optimistic message. Supersonic passenger aircraft is making significant breakthroughs and a strong comeback. It has great potential to provide more economical and reliable high-speed flight services in the coming years. According to the company, Quantianhou is only the beginning. A larger, more advanced model called Dasheng, also known as Monkey King, is planned for commercial operation by 2030. Development timeline and testing goals. The project is structured around a clear roadmap. 2026, first test flight. Quantianhou will conduct its maiden flight, focusing on aerodynamics, heat-resistant structural materials, power systems, high-speed stability and control. 2030, first commercial supersonic flight, Dasheng model. The company's long-term goal is to introduce a fully operational commercial aircraft capable of Mach 4 speeds. If achieved, this would make it the fastest passenger aircraft ever built, flying in near space, 20 to 100 kilometers above Earth. One of the most unique aspects of this aircraft is its planned flight altitude. The company states that the aircraft is designed to operate in near space, defined as the region between 20 kilometers and 100 kilometers above Earth's surface. For perspective, modern passenger jets cruise at around 10 to 12 kilometer altitude. This aircraft will fly 2 to 8 times higher. At such altitudes, air resistance is dramatically reduced. Turbulence is minimal. The aircraft can maintain higher speeds with lower aerodynamic drag. Passengers could potentially see the curvature of the Earth. This is not just fast travel. It's a completely different flying experience. Understanding Mach 4. What does it really mean? Mach 4 equals 4 times the speed of sound. At standard conditions, the speed of sound is about 1,235 kilometers per hour, 767 miles per hour. Mach 4 equals approximately 4,900 to 5,000 kilometers per hour, approximately 3,050 miles per hour. At these speeds, a flight from New York to London could take just 50 to 60 minutes. Istanbul to New York could be completed in under 2 hours. London to Tokyo might take just 3 hours. For comparison, the Concorde cruised at Mach 2, roughly half the speed of Quantianhou's target. No commercial aircraft in history has ever exceeded Mach 2 in regular passenger service. If successful, this would be a milestone unmatched in the history of civil aviation.
The engineering challenges behind Mach 4 flight. Reaching high speeds is one thing. Surviving them is another. At Mach 4, the aircraft encounters extreme thermal and mechanical stresses. Major challenges include 1. Thermal heating. At Mach 4, surface temperatures can exceed 1,000 degrees Celsius due to air friction. 2. Material fatigue. Conventional aluminum melts at around 660 degrees Celsius, far below Mach 4 temperatures. The aircraft requires O. Advanced alloys, O. Ceramic composite materials, O. High-temperature structural supports. 3. Engine technology. Engines must transition smoothly between O. Subsonic, O. Supersonic, O. Hypersonic airflow conditions. 4. Aerodynamic stability. The aircraft needs to remain controllable in thin, near-space air. The company's approach. Sichuan Lingkong Tianxing Technology is currently developing high-temperature ceramic matrix composites, next-generation propulsion systems, structural cooling technologies, aerodynamic shapes optimized for high altitudes. Regulatory, economic, and environmental obstacles. Even if the technology works, several real-world challenges remain. Fuel efficiency. High-speed flight consumes enormous amounts of fuel. The question is, can it be cost-effective for commercial airlines? Environmental impact. Supersonic flight creates high fuel burn, sonic booms, increased NOx emissions, potential climate impact at high altitudes. Airspace regulations. Near-space aviation sits between traditional civilian flight rules, spaceflight regulations. New standards will need to be created for such aircraft. Passenger safety. Mach 4 flight introduces extreme thermal loads, rapid pressure changes, emergency procedure complications. All of these require new safety protocols. The October test flight, Mach 4, achieved. One of the most significant updates came in October, when the company conducted tests of a Yunxing prototype and reported successful speeds exceeding Mach 4. This indicates the project is past the conceptual stage. Real engineering prototypes are already flying. China is taking a lead in the supersonic race. According to Global Times, the program officially entered its engineering development phase after this test campaign. If the 2026 test is successful and the 2030 commercial target is met, we may witness the dawn of a new era where long-distance travel becomes drastically shorter. Business and political relations accelerate. International cargo and logistics evolve. Competitors in the US, Europe, and Japan respond with their own supersonic designs. This technology could redefine globalization itself. Just as the jet age transformed the world in the 1950s, the Mach 4 era could become the next great revolution in transportation.